on this lovely algebraite day. We're going to talk about relation and functions. And two things we're going to attack. We're going to graph relations after we define them. And we're also going to identify what a function is. So let's walk through some vocabulario first. First thing is that we have a relation. A relation is simply this. It's any input that makes an output. And that's it. In other words, you have an input and an output, and that's it. It can be mathematical. It could be English. You put in a word, and out pops the first letter. You put in a name, and out comes the name backwards. You put in a number, and out comes another number. Okay? So all a relation is some sort of an input. So you might see a diagram that looks something like this, where you've got sort of an input thing, and then something happens, and then we have an output. So in and out. That's it. In. That's what a hamburger is all about. Anybody? So let's go. A relation is any input that makes an output. Next is a domain. A domain is the input. What's going in? What numbers are going in? What letters are going in? Generally speaking, with math, though, we'll say what what values are going in. Is it all numbers 1 to 10? Is it only the negative numbers that are going in? Is it only number 6, number 10, number 3? Like what numbers or values are going in? So what would you think range means?
Oh, the output.
Range means the output. Good. So the output, the stuff that comes out. Again, sometimes the output could be one number. Sometimes it could be all numbers between 100 and 112, So it could be all real numbers. Every number comes out eventually. Or it could just be a limited, these 6 numbers are the only ones that are coming out. Okay? All right, we'll skip the vertical line test right now because visually we need to see that in a moment. But let's define what a function is. And like I said, you should marry a function. But a function is this. It is a relation whose domain maps to a specific range term. In other words, it's consistent. It's consistent. So we'll unpack that momentarily.
So it's pretty much saying a relation whose input.
What would that be like? So over here, just on the side, let's say I put in a 3 and out comes a 6. I put in a 2 and out comes a 12. I put in a 3 and out comes a... What do you expect? If it came 18, but wait a tick, what happened here? When I put a 3 in, what did I get? But now I'm saying I get a 3 and... so it's not a function because it's not consistent. However, if I had changed it, so instead of 3, 18, I said 3 actually gives me a 6. Oh, now it's consistent. Every time I put a 3 in, out comes a 6. Here and here. Every time I put a 2 in, which is only once, I get out a 12. So that's consistent. Let's look at example number 1. First off, we're just given some tables about some basketball players. So we're going to find the domain and range. We'll explain that in a moment. And we have to determine if the relation is a function. Remember, a relation is just a number is in, and out comes another number. 78 gives me a 225. A 72 gives me a 180. A 74 gives me a 197. So what's the domain? The domain are just the numbers that are going in. So these numbers are my domain, and I am going to write them in order. Not the order they're written, but chronological order. So I'm going to start with 72. And the next number is a 74. And then the next number is a 75. And then the last number is a 78. My range now, also listed in chronological order, would be these 4 numbers. Now, coincidentally, they correspond. Notice the 72 is 180. And in my new list over here, it's also corresponding. That won't necessarily be the case. They won't necessarily correspond just like they did up in the chart. Okay, notice I'm not repeating any values. There's nothing to repeat, but in the next examples, we're going to see that we aren't going to repeat. Okay, so notice here, why is this a function? So each value in the domain corresponds to exactly one value in the range. So the answer is yes. The relation is a function. The relation is a function. In other words, it's consistent. How do you know it's consistent? Because every time I put in a 72, I get out an 81. Oh, but I only put it in once. That's okay. That's still every time. 74. The only answer 74 gives me is a 197. Notice if I wanted to mess it up a little bit here, you do not have to write this. But I'm saying, let's just say there was another guy who also was 72, that's 6 feet tall. However, he weighed 179 pounds. With that given information, we would say, no, it's not a function. Because 72 gives me 180, and here 72 gives me 179. So this information would make it not a function. But originally, with the original data, it is a function. It's consistent. Everything that puts in will always consistently give me the same type of output. All right, so how do we look at these ones? So take a gander at letter A down below. We're going to find the domain and, whoa, learn to spell. Not rag. Please change that to an E, range. There is another mistake there too. It's not reallation. Ugh. It's actually relation. Delete that A. Sorry. And don't say, oh, but you're just a math teacher. It's okay. No, no, no. Punch you in the neck. All right, so what's your domain? This is how you can briefly write it. You can just say D for domain. I'm going to say colon, and you have to use this funny little squiggle bracket parenthesis. How do you draw that? It's almost like a parenthesis. It's almost like a parenthesis, but it goes like that. And the closed one goes like that. It's tough to draw, but take a moment to get it right. So my domain, where's the lowest number? It's a -4, so I start there. Then a -2, then a +3, and the highest is a 5, end bracket. What about my range? Please. So the range, again, I'm just going to say R for range. I have my little squiggle bracket. My lowest is -1, then I go up. And notice I don't have to repeat because 3 is repeated, so I don't have to repeat that. Now, of course, the question is this a function? And the answer is yes. Look, every -2 gives me a 3. Every +3 gives me a -1. Every +5 gives me a 0. And every -4 gives me a 3. I quickly know, since there is no repeat in the domain, it has to be a function. So the answer is yes, it's a function. Yes, it's a function. Now, of course, when we graph this, the domain and range help us out. Why? Because it helps me see what the high and low is. We often, when we graph, we often start with just a crosshair like that. But it turns out that when we do that, we might not need to go so low or so high. So notice in the domain, my lowest is -4, my highest is +5. So again, these are my x values. My range, the lowest I go is -1, the highest I go is 3. So these are my y values. So when I make my x axis, I'm going to go from -4 all the way up to 5. Please don't count every single one and put in -4, -3, and -2. Just way too much, way too much. And notice for my y value, I don't need to go very low. The lowest I go is a -1, so I don't have to spend a lot of time down here. The highest I go is 3, so I don't need 4, 5, 6, and 7. Okay? I'm going to put a few numbers on there just to establish my scale. 2, 4, and 6 along the line. -2 there, -4. 2 going up, and 4 there, and negative 2 going down. So now let's graph what we have here. So we do need to see the table. And the table says my first point is negative 2, negative 2, 3. So negative 2, positive 3 is right here. Next, 3, negative 1. Positive 3, negative 1 is right there. 5, 0 is right here. And negative 4, positive 3 is right there.